Hi guys, my name is Brittany and today I'm going to be talking about alkanes, some of their properties and how to name them. First off, what is an alkane? It is a saturated hydrocarbon. So alkanes contain only carbon and hydrogen atoms. Super easy, my favorite part about organic chemistry. So saturated hydrocarbon, that means it has the maximum number of hydrogen atoms bonded to the carbon atoms. That means it only contains single bonds. There will not be any double, triple bonds in alkanes. They have a general chemical formula of CnH2n plus 2. I apologize, I could not get that formatting to work on here, but I think by now we all know what the formatting of that is supposed to look like. I did insert this chart that Dr. Marshall had in the lecture just to kind of show going through here, like one number of carbon, CH4, that's a methane, 2, ethane. And then here on the next slide, I did an example of the formula. So it's again CnH2n plus 2. So for propane, if you go back here and look, propane has 3 carbons. So if you plug that into the formula, C3H2 times 3 plus 2, that gives you C3H8. And if you go back to double check, that is exactly what that says there. And again, for another example, we did pentane. So for pentane, I went back here. Pentane has 5 carbons in it. So for the formula, you plug that in, C5H2 times 5 plus 2 gives you C5H12, which is right here, correct. So that just makes it a little bit easier. It's not too bad for these lower numbers. We can memorize those, but once you start getting to the larger numbers, like given here down at the bottom, it might not be so easy. So it's good to know that generic formula. Moving on to getting into naming the alkanes. So the suffix for an alkane is ane. And then your prefix is going to depend on the number of carbons in the longest carbon chain that you find. So I just put the most common prefixes that we obviously use here in this class. So 1 is methane, 2 is ethane, 3 is propane, 4 is butane, 5 is pentane. I also just noticed that this P is not underlined. That's supposed to be underlined as well. 6 is hexane, 7 heptane, 8 octane, 9 nonane, 10 is your decane, and then so on. It keeps going. As far as skeletal structures, these are also called inalkanes or your straight chain structures. Carbons are located at every end and bend of these. So you've got a carbon here at the end, here at the end, 2, and then you got 1. This is a lot harder to draw on screens than it looks. 1, 2, 3, 1, 2, 3, 4. So you can number your carbons that way, and then your hydrogens are implied. Let's see, how do I screen? Okay, so your hydrogens are going to be implied. You don't have to draw all those out for this. We also know that carbon wants to make 4 bonds. So you can tell here, like this carbon is already bonded 1, 2 times to other carbons. So you know that there's going to be 2 hydrogens on this one. Again, remember your formula. And then you have alkyl groups as substituents. So that is similar to an alkane, but 1 hydrogen is removed. And that changes your suffix from ane to il, YL. So methane will become your methyl group, ethane becomes an ethyl group, propane becomes a propyl group. And then it gets a little bit more tricky with groups like isopropyl, butyl, sec-butyl, tert-butyl, all of those. Those are named based on the order of the carbons and the hydrogens. And then also there is this R, if you ever see that in chemistry, that is the generic for an unknown alkyl group. So we know it's an alkyl group there, but we just don't know exactly what that is. Here is a picture I took from the internet to help with the ordering of, I don't know how to move this out of the way. Oh, I can make myself a little smaller. Oh, there we go. Okay. This helps with the ordering of the carbons. So a primary carbon is going to be a carbon that's only bonded to one other carbon. So this one here is a primary carbon. You see a carbon here, it's only bonded to one other carbon and then 3 hydrogens. A secondary carbon like this one is bonded to 2 other carbons, so one here, one here. Tertiary carbon bonded to 3 other carbons, 1, 2, 3, and then there's an oxygen there, so that doesn't count. And then a quaternary carbon is bonded to 4 other carbons, 1, 2, 3, 4. Hydrogens can also be numbered like this, but they can only be ordered up to tertiary, and they are numbered in relation to the carbon that they are bonded to. So a secondary carbon here, well, that would be a secondary hydrogen as well because it's bonded to a secondary carbon. And the reason that you don't get quaternary hydrogens is because that just doesn't exist. Like this carbon here has already made its 4 bonds. It doesn't have a hydrogen attached to it. So that's why you won't see a quaternary hydrogen. And then it gets a little trickier. Your sec-butyl if your secondary hydrogen is removed, or a tert-butyl if your tertiary hydrogen is removed, if we're going back into what I was talking about before. You can also have cyclic alkanes. These are pretty much the same thing. Basic rules still apply, but cyclo is added as a prefix. So this would be a cyclopentane, 1, 2, 3, 4, 5 carbons. You just add your cyclo before, cyclopentane. And then for here, 1, 2, 3, 4, 5, 6 carbons. So that would be a cyclohexane. So naming alkanes, a little step-by-step here. So first you're going to find the parent chain. So you're going to look for the longest continuous chain of carbons. It'll be the base name of the compound. There could be one or more chains of the same length. So at that point, you find the chain which has the most number of substituents. Sometimes there will be shorter chains. You always just want to go with the longest. Then you are going to number the parent chain. So begin with the end nearest to substituent, number the carbons of the main chain, and then number them so that you have the lowest numbered substituents possible. We'll go into this a little bit more later. Then you're going to name your substituent groups. For this presentation, we're only going to focus on our alkyl groups, and then like our isopropyl, sec-butyl, that stuff. It goes into further stuff with your other groups, but for this one, we're just focused on alkyl groups. So you're going to name the substituent groups and their location, so which carbon number that they are on. Continuing, so then you are going to number the substituents, numbering from left to right or vice versa, so that the lowest possible numbers are in front of the substituents. If you have multiple groups, if you have 2 or more substituents, you're going to list them in alphabetical order. So if you have methyl and ethyl, you'll list your ethyl first, regardless of what number is first, like whenever you're naming it. And then if you have 2 or more of the same substituents present, you're going to use prefixes like di, tri, tetra, etc. You can repeat the numbers. So say you have 2 methyl groups, you can say at carbon 3, say 3,3 dimethyl, but you don't have to repeat the methyl more than once, just the number, and then use your di, tri, tetra, whatever that you need to use to name that. Let's see. If the same substituent numbers can be listed from either direction, the substituent listed first alphabetically gets the lower number. Prefixes are not included ever in the alphabetical part of it. And then branch substituents are numbered from the carbon attached to the present hydrocarbon. The name of the branched substituent is placed in parentheses. And then a few examples I put in here. So this is our first one. So first thing I did was numbered it both directions. So 1, 2, 3, 4 with blue. You also could have done it from here, 1, 2, 3, 4. And then numbering the other direction, 1, 2, 3, 4, or 1, 2, 3, 4 with red. Either way, we know that our longest carbon chain is 4 carbons. So this is going to be a butane for our base. And then we are going to name it with the substituent being the lowest number for this one. So that's going to make blue correct because the substituent is a 2 for the blue numbers. It's a 3 for the red. So blue is correct. So then this one's easy. It's just going to be a 2-methyl. This is a methyl group because there's only one here, one carbon. 2-methylbutane is the name of this one. Our next one, a little bit harder. So we numbered it both ways again, starting from left to right, 1, 2, 3, 4, 5, 6, 7 with our blue. And then I numbered it the other way, 1, 2, 3, 4, 5, 6, 7. We have 3 different substituents. They are all methyl groups. So for our blue, we have a methyl group on 2, 3, and 4. Red, we have one on 4, 5, and 6. The 2, 3, and 4 is going to be lower in the number amounts. Not only is it closer, but it's lower in numbers. The total is 9. And then for the red, it was a total of 15. So the blue is going to be correct again because the substituents are all the lowest total number. And then that will make this a 2, 3, 4. Oh, I did that wrong. Trimethylheptane. And I cannot draw. I apologize. That's incorrect. Set that right there. I think I probably messed that up on another one too. We'll see. Okay, next one. No, I didn't. Okay. The last one that I have here. So our parent chain is what we're going to number first. So 1, 2, 3, 4, 5, 6 for our blue. 1, 2, 3. And you could have gone 4, 5. Or 4, 5, 6. 4, 5 would have been there. Either way, 6 is going to be our longest carbon chain. So this is going to be a hexane. Our substituents, this one's a little bit trickier. We have, if you go onto the blue numbers, we have 2 substituents at 3 and then 1 at 4. As for red, you have 1 at 3 and then 2 at 4. So again, blue, just barely, is going to be the lower number. So that's going to be the correct way that we'll look at this one. And then we're going to name our substituents. So these ones, this is methyl, and there's 2 of them, so that's actually dimethyl. And then this one is an ethyl group. And then we're going to list them alphabetically. It doesn't matter that this is lower than this one. It's still going to be alphabetically. So we're going to have our 4-ethyl, and then 3, since there's 2 of these, dimethyl. Hexane is how we're going to label that one. And I did remember the di on this one, so go me for part of it. Next slide. We are done. If you have any questions, please ask. I inserted pictures of my dog, Maisie, one when she was a puppy and one from a couple days ago on our walk, just because everybody loves dog pictures. So that's all we have. Like I said, if you have any questions, please ask and I can clarify as best as I can. Thank you for watching.